If a given quantity of heat increases the temperature of 150 grams of water from 9 degrees centigrade to 15 degrees centigrade and increases the temperature of an equal volume of oil weighing 100 grams from 9 degrees centigrade to 25 degrees centigrade, calculate the ratio of the specific heat of oil to that of water. Solution: heat given to water Q is equals mCT is equals to 150 times CW times in bracket 15 minus 9 is equals to 150 times CW times 6. Heat given to oil Q is equals to mCT, which is equals to 100 times CO times in bracket 25 times 9, which is equals to 100 times CO times 16. Heat supplied to water is equals to heat supplied to oil. 100 times CO times 16 is equals to 150 times CW times 6. CO over CW is equals to 150 over C is all over 100 times C. This is equals to 0.56. Example 2. A heating coil of resistance 13 ohms is connected to a 240 volt supply for 5 minutes to boil a quantity of water in a vessel of heat capacity 200 joule per Kelvin. If the initial temperature of the water is 20 degrees Celsius and its specific heat capacity is 4.2 times 10 raised to the power 3 kg per Kelvin, calculate the mass of water in the vessel. Solution: let W be the mass of water. Electrical energy generation is equal to V squared T over R, which is equal to 240 squared times 5 times 60 all over 30 equals to 570,000 joules. Heat absorbed by vessel and water is equal to 200 plus 4.2 times 10 raised to the power 3 in bracket 100 minus 20 is equal to 352,000 joules. In bracket 200 plus omega times 4.2 times 10 raised to the power 3 in bracket 100 minus 20 is equal to 60,000 plus 336,000 W. Heat gained by vessel is equal and water is equal to electrical energy supplied. 16,000 plus 336,000 W is equal to 576,000. Taking like times together, we have 336,000 W is equal to 576,000 minus 16,000. Making omega the subject of the formula, we have 560,000 over 336,000, which is equal to 1.666 gram. Therefore, the mass of water W is equal to 1.67 gram. Example 3. A piece of copper of mass 120 grams is heated in an enclosure to a temperature of 125 degrees Celsius. It is then taken out of the enclosure and held in air for half a minute and dropped carefully into a copper calorimeter of mass 105 grams containing 200 grams of water at 20 degrees Celsius. The temperature of water rises to 25 degrees Celsius. Calculate the rate at which heat is lost from the piece of copper when it is held in air. Specific heat capacity of water is equal to 4,200 joule per kilogram per Celsius. Specific heat capacity of copper equals to 400 joule per kilogram per Celsius. Solution: heat lost by the piece of copper mass mCT equals to 120 over 1,200 times 400 times in bracket 125 minus 25 joule, which equals to 4,800 joule. Heat gained by calorimeter and content is equals to mc cc theta plus mw cw theta is equals to 105 over 1000 times 400 times in bracket 25 minus 20 plus 200 over 1000 times cl in bracket 25 minus 20, which is equals to 4410 joules. Heat loss to air is equals to 4800 minus 4410, which is equals to 3390 joule. Rate of loss of heat to air is equals to 390 over 30, which is equals to 13 joules per seconds. Example 4. 250 grams of lead at 170 degrees Celsius is dropped into 100 grams of water at 0 degrees Celsius. If the final temperature is 12 degrees Celsius, calculate the specific heat of lead. Specific heat capacity of water is equal to 4,200 joule per kilogram per Celsius. Solution. Let CL be specific capacity of lead. Heat loss by lead is equal to mlCl/TL is equal to 250 over 1000 times CL in bracket 170 minus 12 is equal to 39.5 CL. Heat gained by water is equal to mw to cw in bracket theta minus theta 2 minus theta 1, which is equal to 100 over 1000 times 4200 times in bracket 12 minus 0, which is equals to 5040 joules. Assuming no loss of heat, heat loss by lead is equal to heat gained by water. 39.5 Cl is equal to 5040. Cl is equal to 5040 over 39.5, which is equal to 127.59. Specific heat capacity of lead is equal to 127.6 joule kilogram per Celsius. Example 5. An electric current 3A flowing through an electric heating element of resistance 20 ohms embedded in 1000 grams of an oil raises the temperature of the oil by 10 degrees Celsius in 10 seconds. Calculate the specific heat of oil. Solution. Let CO be the specific heat capacity of oil. Electrical heat supply is equal to IVT, which is equal to I squared RT, which is equal to 3 squared times 20 times 10, which is equal to 1800 joules. Heat gained by oil is equal to MOCO times 10, which is equal to 1000 times CO times 10, which is equal to 10,000 CO. Heat gained by oil is equal to electrical energy supplied. 10,000 CO is equal to 1,800. CO is equal to 1,800 over 10,000, which is equal to 0.18 joule per gram per Celsius. Latent heat. Latent heat Q is the amount of heat absorbed or given out by a body during change of state at a constant temperature. Latent heat Q is equal to ml, where Q is the quantity of heat, m is equal to the mass of the body, I is the specific latent heat. Unit is joule.